Hello my dear friends, how are you all? I hope you all are good and fantastic. So my dear friends, you are very welcome in our lecture number 2 of number system. Okay, so my dear friends, today we are going to start a new topic. Okay, so without wasting the time, let's start. Yes, so now my dear friends, today we are going to discuss properties of number system. Okay, in previous lecture we learned about the number system, what is number system, what is the classification of number system. Okay, now here we are going to discuss about the properties of number system, means properties of real numbers, properties of rational numbers. Okay, so these things we are going to discuss, and with lot of examples. Okay, so my dear friends, we use numbers in our day-to-day life. Okay, and they are often called as numerals. Okay, so without numbers we cannot do counting of things, date, time, money, etc. Okay, sometimes these numbers are used for measurement. Okay, and sometimes they are used for labeling. Okay, and all the things we already learnt in the previous lectures. Importance of numbers. Okay, so these things we already discussed in the previous lecture. Now my dear friends, here we are going to discuss like properties of real numbers, properties of rational numbers. Okay, how to add the two numbers, how to subtract the rational numbers, how to multiply, how to divide the rational numbers. So like these things we are going to discuss today. Okay, yes, so now my dear friends, here is we are going to discuss properties of real number. Properties of real number. Okay, so now my dear friends, we know very well that real numbers are simply the combination of rational number and irrational numbers in the number system. Okay, I hope you get this point. So my dear friends, there are four main properties of real numbers, which are: first is, my dear friends, commutative property. Commutative property. Second is associative property. Associative property. Okay, third is, my dear friends, distributive property. Distributive property. Okay, and fourth is identity property. Identity property. Okay, my dear friends, so now my dear friends, let's start discussing all these properties one by one. Okay, yes, so the first property is commutative property. What is this property? So my dear friend, let's suppose if m and n are the numbers. M and n are the numbers. Okay, so my dear friends, then the general form will be like this. In this case, in the commutative property, in this case like this, if we add two numbers, like if we add m plus n, or we can add n plus m, so the result will always be same. So the result will always be same. This is for addition. This is for what? This is for addition. So my dear friends, commutative property for addition is that if we add two numbers, like this, if we add m plus n, or we can add n plus n, then the result would be same. Then the result always be same. This is for addition. Now in case of multiplication, if we multiply m into n, or if we multiply n into m, so again the result will be same. So this is for multiplication. This is for, my dear friends, multiplication. I hope, my dear friends, you understand these things. Okay, so now if we take the example in addition, in addition. For example, let's suppose m is equals to 5 and n is equals to 3. They are numbers and they are real numbers, and they are what? Real numbers. Okay. Now, if we do 5 plus 3 or if we do 3 plus 5, then the result is always same, which is 8. Which is what? 8. So, this is the case of commutative property. This is the case of what? Commutative property. I hope my dear friend you understand these things. So now if we see in the case of multiplication, yes, so now in multiplication, like examples are like, let's suppose we have m is equals to 5 and n is equals to 3. We know that m into n or n into m will always same. So now my dear friends, if we multiply 5 into 3 or if we multiply 3 into 5, we get always the same result, which is 15. Which is what? 15. So my dear friends, I hope you understand these things. Okay. So this is the commutative property for addition and commutative property for multiplication. Okay. Yeah. So now, so the next is associative property. Okay. Now in this case, we have three numbers like m, n and r. Okay. We have three numbers m, n and r. They are real numbers. They are real numbers. Okay. So now my dear friends, if we do m plus n plus r, or if we do m plus n or r plus r, then the result will always be same. If we do the last two numbers, if we are adding and then we are adding the first number, or if we add the first two numbers and then we are adding the third number, then the result will always be same. This is the for addition, means associative property for addition. Now if we take the example in this, let's suppose we have m is equals to 10, n is equals to 3 and r is equals to 2. Okay. Now put the values in this equation. Now let's suppose this is 10 plus 3 plus 2. Okay. Which is equals to 10 plus 3 plus 2. What we are doing? We are adding the last two terms. Okay, last two numbers, then we are adding the first number. Okay, and in this case we are adding first two numbers and then we are adding third number, then the result will always be same. Now in this case 3 plus 2 is 5, 5 plus 10 is what? 15 is equals to, in this case 10 plus 3 is 13, 13 plus 2 is 15. So my dear friends, you can see that the result is same. So my dear friend, this is a case of associative property for addition. Okay. Now let's see the associative property for multiplication. Okay. So now my dear friends, we have again same m, n and r. They are real number. Okay. Now my dear friends, in the case of multiplicative, if we are multiplying first two numbers and then we are multiplying the last number, or if we are multiplying the last two number first and then we are multiplying the first number, then the result will always be same. What? Same. Okay. Let's see the example. Let's suppose m is equals to same, and m is equals to 10, n is equals to 3 and r is equals to 2. Okay, put all these values in this we get. Now first of all we have to multiply 10 into 3, then we have to multiply with 2. Now in the second case, First we are multiplying 3 into 2 and then we are multiplying the 10. Okay, so now we get what we get. 10 into 3 is 30. 30 into 2 is 60. Now in this case 3 into 2 is what? 6, and 6 into 10 is 60. So my dear friends, this is same. So this is the property of associative for multiplication. Associative for multiplication. I hope my dear friends you understand these things. Okay? Yes. So now next property is distributive property. Now what is distributive property? So my dear friends, as the name is distributive, means in this we are distribute the numbers. We are distributing this number. So again, let's suppose we have three numbers m, n and r, and these are real numbers. Okay. Now, so distributive property is represented as, let's suppose we have m into n plus r. Okay, we can write it as m into n plus m into r. We can write it as also. In distributive property, we can solve m into n plus r is m into n plus m into r. Okay, so now we are distribute the m in n and in r. Okay, we are distributing m with n in this case plus, and we are distributing m with r in this case. Okay, I hope you get this point. So now let's suppose we have, for example, we have m is equals to 5, n is equals to 2 and r is equals to 3. Okay, now put the value in this equation. We get m is 5 into 2 plus 3, or we can solve it as also 5 into 2 plus 5 into 3. Okay, in this case we are multiplying individually with 5. Okay, so now my dear friend, this will become, here is 2 plus 3 is 5 and 5 into 5 is what? 25. Okay, in this case 5 into 2 is 10 plus 5 into 3 is 15. Okay, so my dear friend, this will become 25 is equals to 25. Okay, so both the results are same. Both the results are same. So this is what? This is the distributive property. This is the distributive property. Now my dear friends, one thing is that if you observe this, there is no associative property for subtraction and division. Okay, we have associative property for addition and multiplication, and we have commutative property for addition and multiplication, but we have no commutative property for subtraction and division, and same we have no associative property for addition and division. Okay, because my dear friend, there is a reason. What is? Here is, if we see in the case of commutative property for subtraction. Now if we see commutative property for subtraction. Now in this case, my dear friends, here is, let's suppose we are taking m and n. There are two numbers, two real numbers. Okay, if we do m minus n or we do n minus m, both the result will different. Both the result will different. For example, let's suppose we are taking m is equals to 3 and n is equals to 2. Okay, if we subtract 3 minus 2, we get 1, and if we subtract 2 minus 3, we get minus 1. So the result will different. Okay, so we can say that commutative property for subtraction is not valid. Commutative property for subtraction is not valid. Okay, same Yes, same in the case of division. So commutative property for division. Let's see. In this case, if let's suppose same we have m and n, two real numbers. Okay, now if we are doing m upon n, this is not equals to n upon m. Okay, let's suppose for example we have m is equals to 2 and as n is equals to 3. Okay, now if we doing 2 upon 3, okay, this is different from 3 upon 2. This is different from 3 upon 2. So we can say that commutative property is not applied for division. Commutative property is not applied for division. So same case is here like in the associative property. Okay, in associative property also, associative property is not applied for subtraction and division. Is not applied for subtraction and division. Okay, I hope my dear friend you understand these things. So now let's move on to the fourth property, which is identity property. This is what? Identity property. Okay, now what is identity property? So my dear friends, identity property is also divided into two parts, which is first is additive identity. Additive identity. Okay, and second is multiplicative identity. Now my dear friends, what is additive identity and what is multiplicative identity? Let's see one by one. First is additive identity. Now my dear friends, what is additive identity? Let's suppose we have a number, m, which is real number, which is what? Real number. So my dear friends, additive identity is that identity if we are adding a number in m, so this will give m. Okay, if we are adding that number in the m, so we get the same number, so that number is what? Additive identity. So what is the number? So if we are, my dear friends, if we are add 0 in the m, then we get same number. This is what? This is m. So my dear friends, we can say that 0 is additive identity. I hope my dear friends you understand these things. So what is additive identity? So my dear friends, if in a number we are adding additive identity, then we get the same number. Then we get what? Same number. So 0 is what? Additive identity. Now let's see the multiplicative identity. What is multiplicative identity? So second is multiplicative identity. So now my dear friends, in this case again let m is a real number, So now my dear friends, if we are multiplying a number in m, so we get the same number m. So this number is what? This number is multiplicative identity, means mi what? Mi is multiplicative identity. So what is the number? So the number is 1. Okay, if we multiply 1 in any of the number, then we get the same result. Okay, so my dear friends, 1 is what? 1 is multiplicative identity. So we can write here as 1 is the multiplicative identity. I hope, my dear friends, you understand these things. Okay. So these are the properties of real numbers. What are these? Commutative properties, associative properties, distributive properties, and identity properties. Okay. Yes. So now, my dear friends, yes. So now let's come on the rational numbers. Okay. Now in this section, we are going to discuss the positive and negative rational numbers. Okay. We know very well that what is rational numbers. So the rational numbers are those numbers which are expressed in the form of P upon Q, which can be expressed in the form of P upon Q. Here P and Q are what? They are integers. Okay. And Q is not equals to 0. So this is the condition of rational numbers. Okay. So rational numbers is also divided into some parts. Like, let's suppose this is rational numbers and it is divided into two parts. First is integers and second is non-integers. Okay. Integers and non-integers, and in the non-integers there are like fractions and decimals. Okay. And in the integers there are like whole numbers, natural numbers. Okay. Understand? I hope you get this point. So now, my dear friends, if you talk about the positive and negative rational number, then here is, you can see that as we know that rational numbers is in the form of P upon Q, where P and Q are integers. Okay. And Q should not be 0. Okay. So my dear friends, rational numbers can be either positive or negative. Rational numbers can be either positive or negative. Okay. So my dear friends, if the rational number is positive, if the rational number, like if P upon Q is positive, then my dear friends, in this case both P and Q should be the same sign. Either they will be positive or they will be negative. Okay. Okay. So if the P upon Q is positive, then P and Q, then P and Q, both numerator and denominator are same sign. If this condition is satisfied, then we can say P upon Q is positive. Let's suppose, for example, if we have P is equals to -3, okay, and Q is equals to -2. Q is equals to -2. So in this case, my dear friends, if we are doing P upon Q, then we get 3 upon 2 minus 3 upon -2, and this minus will be cancelled. We get 3 upon 2. So this is what? This is positive rational number. I hope, my dear friends, you get this point. Now if we talk about negative rational number, so let's suppose if P upon Q is negative, then in this case either numerator is different sign and denominator is of different sign. Means in this case numerator and denominator are of opposite sign, are of opposite sign. Means we are saying that if P is positive, then Q is negative. Okay, if P is negative, then Q is positive. This is the case of negative rational number. For example, if P is equals to -2 and Q is equals to 3, then we get P upon Q is what? -2 upon 3, which is negative rational number. So my dear friends, I hope you understand the concept of positive and negative rational number. So now my dear friends, let's move on. Yes, our next topic is arithmetic operations on rational numbers. So now we are doing some arithmetic operations on the rational numbers. Okay, so in mathematics, arithmetic operations are the basic operations we perform on the integers. Okay, so now let's see how we can perform these operations on the rational number, which is in the form of P upon Q. Okay, now my dear friends, in the case of addition, means addition of two rational numbers, how we can do it? So now my dear friends, we have to add, let's suppose we have two rational numbers, like we have P upon Q and S upon T. They are two rational numbers. Okay, so we can solve it P upon Q plus S upon T like this. We have to take QT as a LCM. This will be LCM. Okay, now this will become P of T plus S of Q. Okay, so this is the method to solve this. For example, we have to add 1 upon 2 plus 3 upon 4. These two numbers are what? These two numbers are rational numbers. So now my dear friends, this will become, so the LCM of 2 and 4 is 4. Okay, and if we divide 4 by 2, we get 2 and 2 into 1, 2 plus, and this will be 3. So we get 5 upon 4. Okay, I hope you get this point. So this is the method of addition of the rational number. Now subtraction. So my dear friends, this is the same like this. For example, we are taking the example directly. So if we subtract these two numbers, if we have to subtract these two numbers, we get, here is 4 and here is 2 minus 3, so we get minus 1 upon 4. So if we observe that this is what? This is positive rational number, and this is what? This is negative rational number. Negative rational number. Okay, now in the case of multiplication, okay, so now my dear friends, let's suppose we have P upon Q and S upon T. These two numbers are what? These two numbers are rational numbers. Okay, now if we multiply this P upon Q multiply by S upon T, now my dear friend, in this case we have to multiply the numerator into numerator and denominator into denominator. So we get what? We get P into S divided by Q into T. What is Q into T? Now let's suppose, for example, we have 1 upon 2 and 3 upon 4, and we have to multiply this. So we get what? We get 1 into 3 upon 2 into 4. Okay, so this will become 1 into 3 is what? 3, and 2 into 4 is what? 8. So we have 3 upon 8. So my dear friends, I hope you understand these things. So now most important thing is division, in the division case. So in this case, my dear friends, so let's suppose we have P upon Q and S upon T. These two are again same rational number. So now my dear friends, if we have to divide like this, P upon Q divided by S upon 2, this is the sign of division. Now my dear friends, in this case we have to change the sign. We have to change the division sign by multiplicative sign. So now for changing the sign of multiplication, we have to do the reciprocal of this number. Okay, so we get P upon Q multiply T upon S. P upon Q into T upon S. So we get PT upon QS. Okay, let's take an example. We have 1 upon 2 and we have to divide 3 upon 4. Okay, now in this case 1 upon 2 into this will be changed. This term will be changed. So it will become 4 upon 3. What is 4 upon 3? So now in this case we have 1 into 4 divided by 2 into 3. So 4 upon 6 is the answer. What is 4 upon 6 is the answer. And if we simplify this, we get 2 and here is 3. So we get 2 upon 3. We get what? 2 upon 3. So my dear friends, I hope you understand these things. I hope you understand the concept of the arithmetic operation on rational numbers. Okay, we can easily do the addition, we can easily do the subtraction, we can easily solve multiplication, we can easily solve division for the rational numbers. Okay, I hope you understand these things. So now let's move on. So my dear friends, as the rational number is represented in the form of P upon Q, which is a fraction, which is a fraction, then the multiplicative inverse of rational number is the reciprocal of the given number. Is what? Is the reciprocal of the given number. So let's suppose, for example, here is multiplicative inverse of P upon Q is the inverse of this number, means Q upon P is what? Q upon P. For example, let's suppose we have 4 upon 7, which is a rational number. Which is what? Which is a rational number. Okay, so now my dear friends, then the multiplicative inverse of 4 upon 7 is 7 upon 4. So this is the answer, 7 upon 4. So 7 upon 4 is the multiplicative inverse of 4 upon 7. Okay, now my dear friend, if you observe this, if we multiply 4 upon 7 into 7 upon 4, we get 1. We get what? We get 1. So the multiplicative inverse is that number if we multiply from the same number, if we multiply the original number, okay, then we get 1. We get always 1. So this is what? Multiplicative inverse. I hope my dear friends you understand these things. So what is multiplicative inverse? If we multiply a number, if we multiply in a number with its multiplicative inverse, then we get always 1. Then we get always 1. Okay, I hope you get this point. Okay, so now my dear friends, so the next property is rational number properties. Rational number properties. Okay, so now my dear friends, since the rational number is a subset of real number, it is a subset of real numbers, then the rational number will obey all the properties of the real number system. All the properties of the real number system. Okay, so some of the important properties of the rational numbers are like, first property is that if, so my dear friends, if we multiply, add or subtract any two rational number, if we add, multiply or subtract any two rational number, then we get always rational number. Then we get always rational number. Let's suppose if we have P upon Q and S upon T. They are what? They are rational number. Okay. Now, if P upon Q, if we add S upon T, or if we subtract, or if we multiply, then we get always the rational number. Then we get always rational number. Then the result will always rational number. Okay, I hope you get this point. So this is the first property. Now the second property is, so the second property is, my dear friends, a rational number remains the same. A rational number remains the same if we divide or multiply. If we divide or multiply both the numerator and denominator with the same factor. So now, my dear friend, let's suppose we have P upon Q. Okay, and we are multiplying both the numerator and denominator with same factor, which is S. Okay, so now, my dear friends, here is we are multiplying in the numerator with the S and multiplying in the denominator with the S with the same factor. So my dear friends, we get, let's suppose, a new number which is R upon T. So this number is always a rational number. Okay, let's suppose, for example, if we have 1 upon 2 and we are multiplying 3 and 3, both the numerator and denominator. So we get 3 upon 6. So we get what? 3 upon 6, which is same as 1 upon 2. So this is also a rational number. Okay, I hope you get this point. So third property is, if we add 0 to a rational number, then we will get the same number itself. Okay, if we add 0 in a rational number, let's suppose we have P upon Q, and if we are adding 0, then we get the same rational number itself. Okay, yes. Fourth property is, rational number are closed under addition, subtraction and multiplication. Closed under addition, subtraction and multiplication means if we are adding the rational number, then we get same the rational number. If we are adding any two, if we are subtracting any two rational number, then we get rational number. If we are multiplying two rational number, then we get same, then we get the number which is always the rational number. Means rational number are closed under addition, subtraction and multiplication. We are not talking about the division. Okay, now closed under means, this closed property means if we are adding two rational number, then we get the rational number. If we are subtracting two rational number, then we get rational number. If we are multiplying, if we are multiplicate two rational number, then we get rational number. Okay, in the case of division, if we are divide, let's suppose if we are divide 1 upon 2 by 0. Okay, so then we will not get the rational number, then this will become, okay, this will not the, yes, we get infinity, so this is not the rational number. Okay, here is, if we divide by 0, then we get 1 upon 0, which is not what, which is not rational number. I hope, my dear friends, so we cannot say that if we divide rational numbers, if we divide two rational numbers, then this will give, yes, then this will give rational. Okay, so we cannot say that. Yes, my dear friends, so the next is, now how to find the rational number between two rational number. Now we have to find the rational number between two rational number. So my dear friends, for finding these, there are two methods. So first of all, my dear friend, let's suppose we have P upon Q and S upon T. Okay, so my dear friend, there are infinite number between two rational numbers. There are lot of rational number between two rational numbers. So there are infinite rational number between two rational numbers. Between what? Between two rational number. Okay, so now let's see how to find the rational number between two rational numbers. So my dear friends, first method is, okay, when denominator are same. When denominator are same. So in this case, how to find this? Let's see. So let's suppose, my dear friends, we have 1 upon 5, okay, and we have 4 upon 5, okay, and we have to find the rational number between these two rational numbers, and we have to find the rational number between these two rational numbers. So how we can find it? So my dear friends, we know that 1 upon 5, after that 2 upon 5, 3 upon 5, and 4 upon 5. Okay, so these two are, yeah, they are the rational number between 1 upon 5 and 4 upon 5. Okay, I hope you get this one. So if the denominator is same, if the denominator are same, then we can find easily the rational number between these two rational numbers. Okay, my dear friend. So now, my dear friend, if the difference between the numerator, if the difference between the two numerator, okay, in this case, if the difference between two numerator is less, and we need to find more rational number. Okay, now my dear friends, now we have to find the three rational number between them. Then how we can find it? There are two rational numbers. Okay, so now in that case, by, okay, then the numerator, then we have to multiply the numerator and denominator of the given rational number. So let's suppose we have to find three rational number. Okay, so for this we have to multiply 3 plus 1 is equals to 4. So we have to multiply 4 in the numerator and denominator in both the rational number, like this. 1 upon 5 into 4 upon 4, we get 4 upon 20. Okay, now in 4 upon 5, if you multiply 4 upon 4, we get 16 upon 20. So now, my dear friend, so now we can find a lot of rational numbers between these two rational numbers, but the rational number between these two rational numbers are equivalent to the rational number between 1 upon 5 and 4 upon 5. Okay, so my dear friends, I hope you understand these things. Okay, now, yes, so now, my dear friends, when denominators are different, okay, so now, my dear friends, we have to find the rational number between two rational numbers which having the different denominator. Okay, so in this case, my dear friends, we have to follow some steps, which is, first of all, find the LCM of the two different numbers. First of all, we have to find the LCM of the two different numbers. Find LCM of numbers. Okay, second is, my dear friends, after finding the LCM of the number, okay, so we have to make the denominator equal to the LCM in both the number. Okay, so my dear friends, let's suppose, for example, here is, we have 1 upon 2 and we have 2 upon 3. Okay, so in first step we have to find the LCM of 2 and 3, which is what? LCM of 2 and 3, which is equals to 6. So now, my dear friends, we have to make the denominator is 6. We have to make the denominator is 6 in both the numbers. Okay, so we have to make the denominator make the denominator is equal to 6. Okay, is equals to 6. We have to make the denominator is equals to 6 in both number. Okay, so now how we can make it? So here is 1 upon 2, and for making it 6 we have to multiply 3 in numerator and 3 in the denominator. So we get what? 3 upon 6. Okay, now here is 2 upon 3, and we have to multiply 2 upon 2 for making the denominator 6, which is equals to 4 upon 6. So now my dear friends, we have 3 upon 6 and 4 upon 6. I hope my dear friends you understand these things. So now we have the denominator same, which is 6 and 6. Okay, now we can easily find the rational number between these two rational numbers. Okay, now we have to follow the method 1. Okay, yeah, this method. Okay, yeah. So now let's move on. Now the method number 2 is, so now my dear friends, in this method find out the mean value of the two given rational number. Okay, the mean value should be the required rational number. In order to find the more rational number, repeat the same process with the old and the newly obtained rational number. Let's suppose, so like we have 1 upon 2 and 3 upon 4. Now we have to find the rational number between these two numbers. Okay, so how we can find it? We have to find the mean value of this number. So this is 1 upon 2 plus 3 upon 4 divided by 2. So this will equals to, so the LCM between these two numbers is 4, and if we divide 4 by 2 we get 2, and 2 into 1 2 plus 4 divided by 4 which is 1, and 1 into 3 this is 3, and here is 2. So we get my dear friends 5 upon 4 upon 2, which is equals to 5 upon 4 into 1 upon 2. So this will give 5 upon 8. So my dear friends, we have the rational number between 3 upon 4 and 1 upon 2 is 5 upon 8. So this is the rational number. So now my dear friends, if we want to find the rational number between this, we can easily find. Okay, so my dear friends, I hope you understand these things. Okay, so now let's solve some problems. Okay, so the question number 1 is 0 a rational number? Okay, can you write it in the form of P upon Q? Okay, yeah, so my dear friends, we can say that here is, we know that a number is said to be a rational number if it can be written in the form of P upon Q. Okay, where P and Q are the integers and Q is not equals to 0. So my dear friends, we can write 0 upon 1, 0 upon 2, 0 upon 3. So we can say that, my dear friends, hence 0 is a rational number. 0 is a rational number. Okay, second question is, now find 6 rational number between 3 and 4. We have to find 6 rational number between 3 and 4. Okay, so now my dear friends, we have to find 6 rational numbers. So we have to multiply 6 plus 1, which is equals to 7 in numerator and denominator in both the numbers. So we get 3 into 7 upon 7. We get what? We get 21 upon 7. Okay, now in the case of 4, we have to again multiply 7. So we get 28 upon 7. 28 upon 7. So now my dear friends, we have 21 upon 7 and 28 upon 7, and between these numbers are 22 upon 7, 23 upon 7, 24 upon 7, 25 upon 7, 26 upon 7, and last is 27 upon 7. So here is 1, 2, 3, 4, 5 and 6. 6 rational numbers are there. Okay, this is our answer. Okay, yes. Next is, find 5 rational number between 3 upon 5 and 4 upon 5. Now my dear friends, we have 3 upon 5 and 4 upon 5. Now we have the denominator is same, but we have to find the 5 rational number. So my dear friends, 5 plus 1 is 6. We have to multiply 3 upon 5 into 6 upon 6, which will give 18 upon 30. And here is 4 upon 5 into, and here is 6 upon 6, which is equals to 24 upon 30. Okay, now here we have to find the rational number between 18 upon 30 and 24 upon 30. Okay, so what are these? Here we can see that this is 19 upon 30, 20 upon 30, okay, 21 upon 30, 22 upon 30 and 23 upon 30. So these are the 5 rational number between 18 upon 30 and 24 upon 30, and these rational numbers are equivalent to those rational number which are lie between 3 upon 5 and 4 upon 5. So I hope you understand these things, my dear friends. Okay, so this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.